Okay, so this problem we're going to take f times g of x. So let's take the f of x part, which is the fifth root of x, and let's times that by the g of x part. Well, when we times it, we need to make sure we are timesing the whole thing, not just the first term. Okay, now it might be easier. Right now it's in radical form. Maybe it'd be easier if we wrote it in exponential form. So this would be x to the 1/5 power times 3x to the 1/5 power minus x to the 14 over 5 power. Now I'm saying that might be easier because if you remember your exponent rules, when you times two things, as long as they have the same base there, the x is the same base, then we can just add their exponents together. So this will be 3x, and we would add these exponents together. 1/5 plus 1/5 makes 2/5. And then when we so that's distributing this one through. Now let's distribute it through to this second one here. So I'm going to have x to the 1/5 times negative x to the 14/5. So this is going to be minus x to the, we're going to add the exponents. 1/5 plus 14/5 is going to be 15/5. But that can simplify. 15/5 can simplify to x cubed. And 3x, should put that in parentheses, 3x to the 2/5 can be rewritten as the fifth root of 3x squared. So that's where they got their final answer here. And they wrote the root part second. I wrote it first. Either way is correct. So a lot of times it can help you if you change it from radical form to exponential form. And the way, again, that you do that is whatever power is inside here is going to be the numerator of your exponent fraction, and whatever type of root you have, so the index, is going to be the denominator of your fraction. So the most common one that you'll see is something like this. If you have the square root of x, it's the same thing as x to the 1/2. If you have the cube root of x, it can be written as x to the 1/3. Let's say you have the cube root of x squared, that would be x to the 2/3. So you always just take what's inside here as the top, the numerator, and what kind of root it is, or the index, as the denominator. And that's how you change from radical form to exponential. And again, it's easier for a lot of people to simplify these once it's in exponential form, because we can use the rule where we just add the exponents together as long as the bases are the same. So I hope that helps. Let me know if not, and I can go into more detail. Thanks.